Good morning, everyone. Hope you've all been having fun, and I'm sure none of us are actually awake yet, but that's okay. So I've been involved in open source for a number of years now, and one of the projects I've worked on is called Johnny 5, and one of the things we're known for is good documentation. So this is kind of where a lot of this sort of stems from. By the way, you can find me online at Nebrius on Twitter, GitHub, all the usual places. And I've started doing something kind of new with talks as well. I have a landing page you can go to. The URL's on this slide. It's going to be on all the subsequent slides, too. And it's got like slides, more resources, and things like that. So, all right, let's talk about how we write good documentation. Now, I want to start off with a bit of a caveat. I'm specifically going to be talking about documentation for small to medium-sized projects. These are things where your documentation is in a single README. We're not talking about Webpack, React, things that have enormous documentation sites and stuff like that. Those are kind of a different beast entirely. All right, so before we get into how you document, I want to talk a little bit about the mindset that goes into it. Because creating good documentation can feel a bit like an art a lot of the time. And there are some skills that go into it that can be kind of tricky to sort of embody at first. So the first mindset that we really should keep in mind is that we are not our users. As library authors, we have kind of a unique mindset going into this. We wrote all the code, so we know, every little nook and cranny of this. We know how it works sort of just intrinsically. So when we're writing documentation, we're coming from pretty much the exact opposite point of our users, especially someone who's coming to our project for the first time and has none of this knowledge. So we need to remember that we're not writing documentation for ourselves. We're writing it for someone who is really different than us. The next one is that users' knowledge is highly variable. When we're writing documentation, we're not just writing for one person or one type of person. We're writing for a bunch of different types of people. We're going to be writing for users that have been programming for 20 years. They have, bring a lot of experience to the table. We're also writing our documentation for people who've been programming for 1 year and are very early in their career. And so these different people, they have different skills, and they tend to learn in slightly different ways, too. We also need to remember that even for people who are skilled, no one is ever uniformly skilled in all types of coding. Some people, even who are highly skilled, tend to have experience in some areas and not others. So they may be skilled in the area that your library approaches, but they may not be. They may be really new. If it's, for example, someone who's been doing front-end for 20 years and they're just getting started in full stack, and your module is a Node.js module, there's a lot of stuff they may not know. So we need to remember that when we're writing documentation, we kind of want to err on the safe side and assume that users don't have a lot of background knowledge necessary to understand what our module does. All right, so that out of the way, let's kind of get into some nuts and bolts. In this case, I'm talking about documentation, like I said, on a small scale. This is the thing that would go in a README, and thus would show up on the NPM download page. And there's a couple of parts that I think every README should have. Now, this is based on experience that I've done, once again, in the Johnny 5 project. So this is the views of several people, but not everyone's. I'm sure a lot of folks would quibble with a lot of the details in here. So the very first part in a README is the introduction. This is the part that comes right underneath the name of your module on your GitHub README. And there's a couple of things that you want to do here. The first thing is the introduction needs to be short, very short and to the point. This is the point where you're really selling your module to users. It's almost like a sales pitch in a way. You're trying to convince people to use your module in this. So what you want to do first is say what it is as clearly and concisely as possible. And you also want to say why it is valuable. This is also where you put Gitter badges and things, or GitHub badges in here, which could be Gitter and other things like that. So as an example, I'm going to show off the README for Raspberry IO, which is the big module that I maintain. Well, I say big, it's very medium-sized. And I've been doing this for a while. It's a part of the Johnny 5 project. So you can see I have a description here in which I say very early on what it is. It's an IO plugin for Johnny 5. And I say what Johnny 5 is. I don't assume people know what Johnny 5 is coming to my module. I say it's a Node.js robotics platform. And I say basically the relationship between Raspberry IO and Johnny 5. And I say it enables Johnny 5 to run on a Raspberry Pi. Then I talk about where you can find more documentation about it and things like that. Normally, you'll have more badges than this, hopefully, such as unit test. Raspberry IO is actually a little unusual in that since it's hardware, unit tests actually have to have hardware backing them. So Travis doesn't exactly support running things on a Raspberry Pi these days. So the next section is system requirements. You want to let people know what they need in order to run your module, because it can be really frustrating. I've encountered this sometimes where I want to use a module, I start using it, only to kind of get a ways into the process to realize that, oh wait, I can't use this where I want to use it. Maybe I'm trying to run something on a Raspberry Pi, and this is a native module that doesn't support ARM processors. Or maybe there's something else like that that means I can't use it. And so in these cases, we kind of want to do our users a favor and just guide them actually away from our module towards something else. And so this is what they look like for Raspberry.io. So again, Raspberry.io runs on hardware, so it's a little more complicated than most, but I kind of want to show that anyways. In this case, I say which versions of the Raspberry Pi are supported, which is all of them except for the very first one. And I talk about operating system requirements, which is something else you want to have. Hopefully, we support every operating system, but realistically, a lot of us aren't going to be testing on like AIX and some of the more esoteric operating systems that Node itself supports. In my case, this Raspberry.io only runs on one operating system, and that is the Debian variant that's been created for the Raspberry Pi. And I only support a certain version and newer because there's some weird like GCC build requirements. So figure out what are the requirements for your module. And by the way, every module does have an operating system requirement, whether we realize it's there or not. I'm sure none of us are testing to make sure our modules work on Windows 2000, for example. And we shouldn't be testing to make sure we work on Windows 2000. And then finally, we should also say which version of Node we support. And again, every module only supports certain versions of Node. I'd be willing to bet that no one's module in here runs on Node 0.4. And we shouldn't be supporting Node 0.4. But where that cutoff is a decision we need to make. And so we want to make sure that we understand, A, what that is, and B, that we make sure that users are aware of that. So in my case, I support all non-end-of-life LTS versions, as well as the latest version. So I mentioned that here. Now, this can also be, sometimes there can be weird setup things that you also have to know about your system, and so I have a link to a much more complicated one we can talk about here. And also, I can just talk about weird installation things. I have this little warning. A strange side effect of Raspberry.io, you have to install it as a normal user and run it as a root user. Weird reasons why, you can talk to me later, but I wanted to make sure to point that out. And one way that you can really work on figuring out what this is if you have had this module for a while, look at the issues that users are filing. Are there common things that people get hung up on when trying to set it up? Like if users are filing issues over and over about something, that could be a great thing to put into your documentation. Which, by the way, is actually how I got this warning in here, is because users were filing issues in the earlier days. So the next section is installation. You want to tell your users how to install and use your module. This is usually an npm run command. It's most of the time a pretty short section. Sometimes it can be a little bit longer. And so this is what it looks like for Raspberry.io. Like I said, it's pretty short and to the point. It's just npm install blank. But we want to make sure we have this, and I always recommend putting it in backticks as well, because we want to have something that users can copy and paste and then run in their terminal. And this does need to be complete enough that users can copy paste everything and be up and running. If there's any step that you have to do for that installation that's not here, not copy pastable, you're going to get a bit of user fall off. Users are going to run into issues at this point in time. There's always going to be someone who skips a step or something like that. So you want to make sure it's here, because you really want to help your users get through that install process and get up and running with your module. Because if people run into problems with installation, that's usually a really good chance that they're going to go find something else. So the next section is usage. Once they've installed it, they're ready to actually write some code and run some code, you want to give them a basic idea of how to use your module. And so you can think of this as a tutorial and a common example. This isn't examples of everything, but you want to think of what is the most common way people will use your code, or at least the most demonstrative example for people to use your code. And you want to put that here. In this, I like to think of this almost like a tutorial. So you're going to have your code, and you're also going to have a description of what this code does. You want to give them an idea how to use it, and you want to get people up and running quickly. This is not comprehensive at all, and this will normally only demonstrate a small piece of your module, but it is a getting started guide. I usually see it called usage, which is why I call it here. Getting started is also applicable. Even example would also work. So here's the one that I have for Raspberry.io. These sections are starting to get longer, so I'm not going to show the entire thing to you and run through all of them. But you see I have usage with a sort of a brief description at the top, and then you can't see it on the screen, but there's a much longer description below it that talks about what every line of this code does. You want to make sure that users can, again, copy-paste this code. That copy-paste ability is really important. But they can copy-paste this code, they can run it, and it will actually work. It will do the thing that you says it does. And that sounds really simple, but I've actually seen this get hung up a lot. Oftentimes, we'll create our examples, but they'll have syntax errors, we'll leave a line out and stuff like that. We want to make sure that we actually run all of these examples ourselves and make sure that they work exactly the way we think they do. Because if users copy-paste code, and as soon as they run it, they get a syntax error, or it crashes on startup, or anything like that, that's another point in which users are going to say, oh, this bug, or this module is like buggy and stuff. I'm going to go find something else. So keep in mind, there's this theme I'm starting to develop. At each point, if users run into issues with these steps, that's a good chance where they will go and find something else and not use your module. So the next section is notes. A lot of times with our modules, there can be things that we need the users to know. This can be common bugs that are encountered. Maybe there's something that's a little non-obvious about how to use our modules. Maybe there's an implication or a requirement from the operating system, from Node or something else, where we have to sort of work around, and there's like just kind of an ugly API, something clunky, right? These happen. And so a note section is a really good chance to explain that, to make sure that users are aware of these like gotchas and things like that. So there are a ton of these for Raspberry I/O, by the way. Hardware is pretty tricky. This is one of the longest sections in my README, in fact, because there's a lot of things that I found trip up users. In this specific case, referring to the names of pins on the Raspberry Pi is actually kind of complicated, so I call that out. And also call out how to use various peripherals. So I2C is a communication protocol. You can think of a lot of it as like USB that was shrunk down for tiny microcontrollers. But when you're using it, there's complications on how you have to set up the Raspberry Pi, like enabling it for use here, disable certain other use cases, and just like there's some trade-offs there. And so you want to make sure that, in my case, I'm making sure the user is aware of these trade-offs, so that way when they go and they follow my steps, they are sort of like, wait, why doesn't this other thing work? I used to get a lot of issues on that, by the way. So the next section is the API section. And I think this is actually one of the most important, in part because it's one of the ones that I see done the least well in practice. So this is where we document the entirety of our module. We show every single method, every single event, every single class, and we say how it works. So this is the point, like I said, we have different users coming in at different experience levels. You can think of this so far as having been like a funnel. We're starting with people super new, and as they go down the README, it's almost like the user is getting more experienced as we go. So this API section, this is where people will go once they understand the basics of your module. And so we want to make sure that this is complete API documentation. And I really do mean complete. Like every single last thing is supposed to be documented here. And unfortunately, I see a lot of people fall down on this. And a lot of modules don't really apply to this. It's not really complete. It may feel like it, but it's not quite there. So this is what it looks like for Raspberry I/O. So I have the API, and the first thing I'm showing here at the bit you see is the documentation for the constructor for Raspberry I/O. It's often a thing we tend to leave it out, but we can see every single possibility for how we call it. There are no optional arguments. This is a pretty straightforward constructor call, but it takes an object, or an optional object, which you can see is marked as optional. And with this shows how you can configure Raspberry I/O. So like these are the basic sections. I want to go a little bit more into documenting the API. Like I said, this is the part I see that seems to trip up most module authors. So I'm going to go through a set of rules on how you can really come up with really complete API documentation. Because it turns out it's actually kind of algorithmic in how we do this. I wouldn't say it's easy to do, but it's easier than we think once we know what the rules are. So like I said, it's kind of algorithmic. If we think of this almost as like a parsing algorithm for our API, that can help us to make sure that we're not missing anything. So what we do is we start with module exports. We think of this as the very, very top level entry for our module. And this is exporting a variety of things. Some of these are simple things. Some of these are complex things. And so we want to start by documenting everything that is exported. Now this is going to end up looking kind of like a recursive algorithm, because we look at each of these things, we say, okay, is this a primitive? Well, that's pretty straightforward. If it's string, we can document that pretty easily. But if this is a function or a class or something like that, well, that's made up of other parts. So we sort of almost like rerun this algorithm that we ran on module exports on our class. And so then we look and we document everything in the class. But sometimes those classes are made up of other classes. So then we have to descend further and document that class. And if we do this right, we'll end up with, it looks almost like a tree structure in our minds, and every single leaf is a primitive. So you can think of it almost as looking something like this. This is just a random example I made up. We have a module that exports three things: a function, a string constant, and a class. And so we can see that the string constant, that's kind of where we end. That's the primitive. But then the function, we're going to break that down into its arguments and its return types. In this case, they're all primitives because I didn't want to show a giant, massive tree. But you can see we're kind of just descending down until we end up with all primitive values at the end. All right, so now this gets kind of common because there's a whole bunch of different types of things. Functions will be documented differently than objects, which will be documented differently than classes, and then promises, and event emitters, and so on and so forth. So I'm going to run through each of those and what we want to document. Because again, these are, a primitive is always a primitive, so we want to always document them the same. The very first thing we want to document is the type or types of this primitive. And that's basically, is it a string, a Boolean, or a number? And sometimes, in JavaScript, of course, these can be multiple things, so we want to say this can be a string or a number. Now, when we do this, we, of course, always have a description with this. So we want to make sure to document why it might be a string in one case and a number in another. Also, if this is something that a user is providing to your library, say this is a function argument or a constructor option or something like that, then we want to document, does it have a default value or not? And is it optional or required? So if it's an optional value, does it have a default value? And what is that default value? And we want to make sure that these are always explicitly mentioned as well. So if it's required, we want to say it's required. If it's optional, we want to say it's optional. We never want something to be ambiguous on whether or not it's optional or required. This is also where we want to add value limits. For example, if this is a number we're passing in, does it have a minimum and a maximum value that we support? Does it only support positive integers? Does it only support numbers between 0 and 25 for some reason? So we want to document what those are and also why those are. We want people to make sure that they know what these things are. So that way, if they're passing in 26, that they know why they're getting an error. So next up, functions. So functions take in multiple arguments and return a single argument. And we want to make sure that we document all of those. So we start by documenting the return value. And we're kind of following this recursive algorithm. So if it returns a primitive, we'll use the rules that we saw on the previous slide. If it returns another function, we would basically rerun this slide's algorithm on that return type. And if it's an object class, well, we'll see here in a minute what those looks like. And also, same thing with promises. And we also want to do the same thing with each and every argument. Once again, following this recursive structure. For bonus points, you can also document if it throws an exception. Now, in practice, I've not actually seen anyone document this. I myself don't document it. So you're definitely going above and beyond if you do it. But that is something that would probably be useful for us to start documenting as a community. So next up is objects. In this one, we want to document every single property in here. We need to document both its name, the key in our dictionary, and we also want to document its value. And again, this value is following that recursive element. So if an object has a property that's another object, we would rerun the slide's algorithm on that object. For bonus points, we'll document the prototype. This is hardly ever going to be necessary because when we're creating just a plain old object, the prototype is pretty much always going to be object. On occasion, though, folks will set the prototype to undefined. Some reasons for doing that. So if you are doing that library, you definitely want to make sure that you mention that so people are aware that how they can use this object is a little bit different. Next up is classes. So classes are kind of a superset of objects in a lot of ways. So we start off by using that same object algorithm, documenting every single property on our class instance. But we also want to document the constructor. And the constructor is itself a function, so it will follow the same algorithm we saw for functions. And then also, we want to make sure that if this is a class that is intended to be inherited from, if this is a base class for something that users might extend, for example, if you're working within React, when you create a React component, you are extending the React base class. You want to make sure that you mention explicitly which methods are meant to be overridden. For example, in React, you would want to, if I were documenting React with this algorithm, I would make sure to highlight that the render method is a required override. And you also mention that component did mount is an optional override and things like that. So you want to make sure that you call those out as well. Next up is event emitter, which is a very special case of a class. So with event emitters, you want to make sure that you document every single event that is emitted. So you want to document both its name, and again, this is something I like to put in backticks so that people can even copy-paste that event name just to put straight into their code. And never forget that people will be copy-pasting from your code, so you want to kind of enable that. And also you want to document every single argument in that specific event. Again, following these recursive rules. So if an event emits a function, you want to use that function rule, which will then call the primitive rules and whatever else. And finally is promises. So promises are also, again, kind of unique objects. So you want to document what are the arguments that this promise resolves to whenever it successfully resolves. Again, following these rules. But we also want to document how it rejects. And promises can reject in multiple ways, at least in theory. So we want to make sure we say the different ways it rejects and what the arguments are when it rejects. Does it emit an error object, or a string defining the error, or a number constant? Hopefully we're always emitting error objects. That is definitely a best practice. But you want to document whatever you're doing in each case. Also, I want to kind of highlight something that this brings out, is that error handling is very explicit in promises. This is one of the nice things about promises. Whereas in callbacks, there's not an explicit error thing. But we always do error first callbacks. So if you're documenting a callback in Node, we're using that function, the function algorithm. We're documenting our arguments to this function that first will be an error. And so that would be a really good opportunity where you would say the first is an error, its type would be undefined or error object, and then you would actually document what are the different error cases. It's really, and this is a really important thing, and this is another part that I tend to see a lot of documentation sort of fall down on. They tend to only document these success cases. They actually don't talk about the ways in which it fails, at least not in a lot of depth. And we really want to do that because if we can write proper error documentation, that encourages our users to write proper error handling. And this is one of the cool things about documentation, is that when we write it correctly, we can kind of steer our users into writing better code themselves, at least to some extent. And as I've been saying, documentation is really key to success whenever we're writing an open source project. I would actually even go so far as to say that the documentation is more important than the code itself. I mean, we have to have code, but we can write the absolute best code in the world, but if there's no documentation to go with it, no one will use our module, right? This is not going to happen. However, if we write mediocre code, not great, not something we're proud of, but kind of gets the job done, but has good documentation, we will see really good usage of that module. However, of course, what we really want is great code and great documentation, which we'd all strive for. But if you have to make trade-offs between code and documentation, don't trade off on documentation, because that's a really good way to make sure people won't use your module. Great documentation is how we really generate usage. This is how we generate usage numbers. It's one of those critical components. Kind of like we saw in the talk, I believe, on the first day about how to pick a good module. We look at has been updated recently, how many contributors, things like that. Well, documentation is one of those things. It's usually sort of a second step in our evaluation of a module. But if someone goes to a README, I think we've all seen these modules on NPM. We go to the README, and there's 3 lines there. We're just going to go, next, move on to the next module. So really good documentation is how we make sure that we attract users to our module in the first place. And it's also how we make sure that we retain our users. This is one of the big ways that leads to frustration or to happiness with our module. If the people can go and use the documentation, they follow it, and things just work as expected, that's what makes for retaining a good user. And this is, to be fair, all kind of table stakes. It's not, the unfortunate thing is when we write really good documentation, we're never going to hear about it, right? The only time we hear about documentation is when it's bad. And I know it's not a great motivator, but that is nonetheless something we always have to keep in mind. Because without good documentation, we don't get users, we don't get traction, and we don't grow into one of those really big modules one day where we're going to have some fancy website like React and GitHub. With that, I want to thank you all for listening.